is based on a blog post that we published back in December of 2020. And you notice it's been updated as recent as March 8th. So I'm actually recording this on March 9th, but you might not see it till April, or maybe you're even watching it in 2023. If you click on that last updated, it'll take you down to the bottom where you can see the PRs that we merged to upgrade it to the latest releases. And mostly it's a JHipster 770 thing, but it also uses HAProxy, the latest version, as well as Redis, the latest version. So if you go back up to the top, there's a GitHub icon here you can click on to go to the GitHub repo. And in here, this is a completed example, so if you just want to clone this and run it, there's all kinds of instructions here in the README. But what I'm going to do is just use this demo.adoc file. And so adoc stands for ASCII doc, and if I click on the raw version here, you'll see it renders quite nicely with my ASCII Doctor plugin. And I'm going to put this on the left, and then I'll open up a terminal on the right. And you might be asking, why is this important? Well, it's important because Spring Security by default, if you're using its OAuth 2 login feature, which I think should be called OIDC login because OAuth 2 doesn't have anything to do with authentication, that's OpenID Connect, it'll actually store the access tokens and ID tokens in your session. So if your session expires, then, well, you're not logged in anymore. So we might do another post on how to do authentication patterns for expired sessions, but for the moment what I'm going to show you is how to keep those sessions, intact in Redis. And so if a node failure happens, then you'll be good to go. So I'm going to start by just verifying the prerequisites. Java 11. I have Java 17, so let's do SDK. I'm using SDK man for this. You can get it from sdkman.io. SDK default Java 11-open, I think it is. Nope. SDK list Java. Looks like I got that one from Corretto. Keep going. Java.net, local only. It's here's the one I want. So quit that. SDK default Java 11.02 open, and now I'm using Java 11. Okay, and then JHipster 770. So check that version. And then Docker I have installed, and the Okta CLI. So it looks like all our prerequisites there. We're good to go. And if we just look at our table of contents here, we're going to build a microservices architecture with JHipster. We'll add authentication with OpenID Connect. We'll configure Spring Session and Redis, and then we'll show you using HAProxy how to route traffic between two instances of a microservice, or actually a Spring Cloud Gateway, and then keep everything intact. So if you were to refresh the page and one goes down, you didn't lose anything. So you can start by installing JHipster here. If you don't have it installed, that's the command npm install -g generator JHipster. I already have it, so I don't need to install it. And then I'm going to use a JDL sample. JDL stands for JHipster Domain Language, and I'm going to use this microservice e-commerce store for apps. So we'll start by creating a folder for the project. I'll do this in my downloads directory. If you're using OhmyZSH, you can actually do take Spring Session Redis to do the exact same command that I just did. So that's pretty slick. And then we'll copy that JDL locally and rename it to JHipster Redis. So now if we were to open this up in IntelliJ and open that JHipster Redis file, you'll see it's got application definitions for our store, for a product, for an invoice, and for a notification. So just a simple microservices architecture. It's got a bunch of entities down here that belong to the various microservices as well. And so it uses authentication type of JWT by default. So let's change that to OAuth 2. And then it uses Gradle. We're going to change that to Maven. And if you like Gradle, of course, this tutorial will work. Just some of the commands will change. The only reason I'm using Maven here is because, well, the person that wrote this tutorial actually did with Maven. And so, hey, that's what I'm going to use. And so now we've updated everything. You can see the instructions on the left here tell you what it looks like. And it looks just like it does on the right. And then we can run this JHipster JDL command. So JHipster JDL, point to that JHipster Redis JDL. So you can see that took about 2 minutes and 40 seconds. I did try to do this screencast on my new MacBook Pro M1 recently, and it failed because there's some Docker containers that need to have a flag of the platform for AMD 64. So when I did this same command on it, it took about 2 minutes. So you can see it really depends on your hardware, your internet connection speed, how fast all of this happens. I should mention too that I'm using Node 16. I didn't mention that in the beginning, but if I read Node version there, you'll see I'm going to create a Docker Compose directory so we can run everything. JHipster has the ability to basically generate a Docker Compose file that has all your microservices in there, as well as the JHipster registry, which uses Eureka server to coordinate the communication between all your microservices. So that can be very handy to run everything without having to, cd into each directory and run a Maven command or a Gradle command to start them up and make sure all their Docker containers are running that they depend on. So this is just easier. And in here we'll run JHipster Docker Compose, which is a sub-generator for JHipster. It'll prompt us with some values. We want to choose microservice application, Spring Cloud Gateway, and then it's located in the parent directory. And then you select these with spacebar arrow keys. We don't want to use any clustered databases, and for simplicity we're not going to have monitoring, and we're going to use the good old worst best practice ever. Not worst best, just the worst. Using admin for the admin password. So make sure and change that, but if you're not going to check it into source control, it probably doesn't matter because you're just trying to get things working right here. So you'll notice it gives us an error about, hey, we don't have any Docker images for these various microservices. So, run these commands in these directories. So we'll start with this one here, and we'll do it in that invoice directory. And we'll do -d skip test so it happens a little faster. And then we'll do another one in the notification directory. And then product and store. And you might notice it took about a minute to build those microservices, and then the store, which is the Spring Cloud Gateway, took about 2 minutes to run. The reason that took longer is because that's where all the front-end files are located. So this actually generates a monolith UI in a sense. And we do have support for micro front ends, but that's a video for a different day, so I won't go into that. I'll just exit out of these. And then I'm going to go into that Docker Compose. And by default, this generates a Docker Compose file that uses Keycloak for authentication. And you could start this up and it would use Keycloak and everything would work just fine. And that's awesome if you're on a plane because it's in a Docker container and you don't have to worry about actually, connecting to the internet to authenticate. But I like to show Okta because we're on the Okta Dev channel. So I will go ahead and use Okta CLI to create a new JHipster app. So this is Okta Apps. Create JHipster, and we'll name it JHipster Redis. And it defaults to the correct redirect URIs that you'll need. That 8080 is for the gateway, the store application, and then 8761 is for the JHipster registry, which we'll also configure to talk to Okta. You don't have to, but I like to because, why not use the same authentication for everyone? And so you'll notice this does a few things. It creates an OIDC application with that client ID. It creates a groups claim on the authorization server. It creates a couple groups and adds a user to them. And then it writes everything to a .okta.env file. So if we were to open this up back in IntelliJ, we can see that right here. And it's got an issuer, a client ID, and a client secret. And so what I'm going to do is I'm going to start by modifying Docker Compose to use those variables. And I'm going to do that by modifying each Spring security setting that we have here. This is for the invoice microservice. So we're going to set those values and override them from environment variables. I'll do this one as well for the notification service, for the product service, and the store. And then I'm also going to do it for JHipster registry just because I think it's cool that you can use, a different identity provider for all of them. If you just want to use JWT authentication for the registry, you could just remove this OAuth 2 right here and nothing would be used. It would just use the default of JWT. And so now we'll create a .env file. This is how we set those environment variables. So .env and the root directory and Docker Compose will be aware of this. And then we're going to set up those variables. And we'll grab the values from this file. And this file doesn't like quotes, just to warn you, so don't put them in there. Okay, so now we've configured it for Okta, and there is a way in the JHipster registry, if you're going to this file and actually specify Spring security long class name or long parameter name, it's this one right here. If we were to look here, it's spring.security.auth.client.provider. There's a lot. So if you were to put those settings in here and specify it for Okta, it would override all the microservices. So that's a little bit better way to do it, but I wanted to stay true to the tutorial that was written and do it how the tutorial shows it. So if you want to do it that way, there's this other blog post that I wrote, Java Microservices with Spring Cloud Config and JHipster, and that will go over how to do that. And so now we can do Docker Compose up. I'll do this in a terminal over here. So this will take quite some time to initialize the first time, especially if you're like me and you had to download all those Docker containers, which I would imagine you would if you're new to JHipster. And then you have to wait for everything to kind of start up. And you can see, if you see my screen right here, it's actually going through and color coding the different services so you can kind of see them going. But once you see a message from the JHipster registry, then you can open that up on port 8761, and you should be able to actually log in and see the status of the various services. So let's try that now. There we go. And it'll automatically redirect to login. Let's check our configuration. Maybe we messed something up in Docker Compose. Ah, look at that. We had a little error on the end. So fix that up. Stop everything with Control C. And start them all again. Sorry about that, but at least if you fat finger something when you're copying values into that Docker Compose, then can mess everything up for you. Redirecting to login, and boom, now it works, and it will show us the status of those various services as they come online. We can hit this refresh now button, or you can set this to refresh every 10 seconds, every 5 seconds, and you can also watch the logs to kind of see them coming online. All right, now everything's up and running, so we're looking good there. We can go to localhost 8080 and make sure the gateway is working so we can actually talk to the various services. Now if we log in, since we're already logged into Okta, it'll log us right in, and we could go to, for instance, product order or product and add a new product. So we'll just say beer. I like beer. It's expensive where I live in Colorado here, and let's get a large one. And let's see if I have an image. My hard drive here. Pictures. There we are. Save it. And that's all working. So back to our instructions. We'll put this on the left here. And we're going to basically configure the store now to use Spring Session and Redis. So it currently maintains that user session in memory. It's identified with a session ID. It uses good old-fashioned session cookies to communicate with the front end. And if the store instance crashes, that session is lost. And so one way to avoid losing the session is by adding Spring Session with Redis for the storage, for the session storage, and share it among store nodes. And we'll start by deleting the store image so we make sure when we update it, we're actually updating it. We'll do that with Docker RMI store force. All right, and then we're going to edit the pom.xml in the store project to add new dependencies. Doesn't really matter where you do it, just anywhere in here. And then Spring Data Redis does not pull any client by default. That's why we're using Redis in this case. And to enable Redis for our Spring profiles, we need to add it to our configuration for Spring. So that's in source main resources. We're going to do it in the dev and prod profile. If you wanted to, you could probably do it in the root profile, but again, I'm just going to follow the tutorial. So we need to go to just Spring here. We can add it right at the top. If you want to do it alphabetically, of course you can do that. And store type equals Redis. And then we'll copy that for prod. And then we'll disable it in the tests because we don't want to really deal with it while we're testing. So down here there's some excludes for auto configure, so we'll add this one here. And then we'll also set the session store type to none. So we'll just do it right here. Again, if you want to do it alphabetically, you certainly can, but you know how YAML is, so just making sure and get your indents right, and you should be good to go. And so now we'll cd into store, and we'll run that mvn -p prod verify gib and build it again. While that's running, we can modify the Docker Compose file to set the Redis configuration. So look for the store image. All right, there it is. And then we need to set some environment variables here. So we're just going to set the logging to trace and set the Spring Redis host and the password and the port. And then we're going to add a store Redis as a new service. So you could do it like right here. And make sure and indent it, 2 spaces there, or your YAML will be all messed up. So you can see it's using Redis 6.2 and starts that Redis server. And then as soon as that's done building, we can start up Docker Compose again. Okay, so Docker Compose up. I should mention you might need to tweak your Docker settings under Docker Preferences, Resources. So you can see my CPUs are up there, my memory is really up there, and the swap and everything. So the defaults might not be enough. I think the memory is only 2 or 4 gigs. So you might need to tweak those to start everything up. So if you have any issues with starting everything, make sure and do that. And then if we were to log into localhost 8080 here, and make this a bit bigger, click sign in. Okta's still got our session, so we're signed in. And then if we were to go to product, we should be able to see that beer. So that's all working, and we want to delete it. We could certainly delete it. And then back to our instructions here. It says to run this docker exec command. And you'll notice that's our session that's been stored in Redis. So everything's working. And now what we'll do is we'll add a high availability proxy load balancer that makes it so it'll fail over from one to another if we kill a store instance. So we're going to start by removing docker remove docker compose store 1. Oh, we can't remove a running container, so stop everything with Control C and then try it again. So remove that, and then we'll open up IntelliJ again, and we're going to extract this store definition right here into its own Docker Compose file. So we'll start by grabbing that and taking away those ports, and we'll create a store.yml. Doesn't want to do it, so touch Docker Compose store.yml. And then this needs to start. I don't think the version's that important, but I know the services is. So services, and then store that way. And as long as your YAML's all pasted correctly, everything should work. And then we'll edit this Docker Compose, and we'll add multiple stores, store 1, store 2, that extend that store, and then we can override the ports and have multiple instances. So you can see we have store 1 there, extend store, and let me get rid of that highlighting. And we're just naming it store 1. It runs on 8081 or 8080, and then the second instance runs on 8081, and we'll configure HAProxy to be a service that proxies to either one. So now we'll create an HAProxy.yml. And open that one up and configure it to load from this Docker file. And that's going to be pretty simple here. And we're going to use HAProxy 2.5, and we need an HAProxy.cfg to configure it. Don't need this one. And you'll see it's just a daemon with the maximum connections of 2,000, and it's got some round robining that basically says if the option redispatch right here, it will redispatch the request to another server if the current server is down. So it's going to use cookies and all that and go from store 1 to store 2. And so because HAProxy will listen on port 80, we do need to update our Okta configuration to have redirect URIs without ports in them. So I like to use Okta login as a shortcut. and it does prompt you nowadays. It used to not, but I think that's probably better. And now you can go to your application. Let's make this a bit bigger, and Hipster Redis here, and modify your general settings, and you'll see we have these URIs down here, so we can just add one with no ports. Same down here, and so we're just running on 8080, the default, and then save that. So now we can close that. Back to our instructions. We should be able to run Docker Compose up now. Then we can open up localhost in a new window here. And we're already logged in, so it says to go to the product, entities product, and we'll go ahead and create a new one. Why not? More beer. It's gotten cheaper though, maybe because it's a small. And then it says to check your browser's console and do document.cookie. I actually like it on the bottom, so it's a little confusing, but this will work. Document.cookie. And you can see it's using store1 in this instance, right? In this example over here, it says store2, but so we're going to want to stop store1 using Docker here. So not store2, but store1. And then we'll create a new entity. I'm going to stop that, and we'll say what? How about a soda? And that's only a couple dollars, and we won't add an image. There's a network error there. Oh, it's trying to connect Docker for some reason. I saw this earlier, but I'm not sure why. But here's the thing. If you refresh it and then do it, it didn't make me log in again, right? We're still trying to do some soda, and it's cheap. Now it all works. And so if we were to look at network, and we look at the products and the cookies, you can see now it's using store2. So it didn't make me log in again. There was some weird issue when I tried to create a new product right away that it didn't actually work, but refreshing the page worked. So it's a pretty good solution. Works most of the time. Sorry it didn't work right there. Bad demo, Matt. And so I'm going to give myself a pat on the back because, I made it work without logging in again, which proves that Spring Session and Redis work quite nicely together. And you can find the code for this on GitHub. You can see it was just updated yesterday, and if you just wanted to clone the repo and try it out that way, it's got all the steps to do that. And then of course the blog post that describes everything in more details is available as well. So if you like this video, please follow me on Twitter. I'm at mrabel. My team is at Octadev, and we also have a YouTube channel, which you're probably watching this on right now. So subscribe and smash that button. And come back for more great content about Spring Boot, Spring, and many other cool open source technologies. Thanks, and have a great day.